Good afternoon, everyone. My name is Jae, and I'm an MD PhD trainee at McGill University. And so for my presentation, last but not least, I'll be looking at the cardioprotective effects of caffeine from bench to bedside. So regarding objectives, I'll first be outlining the literature on cardiovascular disease and the role of PCSK9 in LDL cholesterol regulation. And then secondly, examining the cardioprotective effects of caffeine through PCSK9. And then lastly, elaborating on the bench to bedside concept and introducing the McGill MD PhD program. Regarding disclosures, my doctoral research is funded by the 2024 CI Charvania Scholarship. So to start, here are 3 key points regarding cardiovascular disease. Firstly, CVD is the leading global cause of death, where an estimated 17.9 million people died from cause of CVD back in 2021. Secondly, heart disease in North America costs $215 billion each year due to healthcare costs. And thirdly, a major driver of CVD is increased circulating cholesterol levels, in particular LDL cholesterol within the blood. As well, PCSK9 is an enzyme that is highly associated with something called familial hypercholesterolemia, which is when you have a genetic underlying cause of high cholesterol. And what it does is that it's first secreted by the liver, and then it floats around your bloodstream, and then degrades something known as the LDL receptor. And the LDL receptor plays a role in basically promoting the uptake of circulating LDL cholesterol, the bad cholesterol, from your blood and into tissue. So when you have more LDL receptor, you tend to have less LDL cholesterol in your blood, therefore being cardioprotective. And those with a loss of function mutation against PCSK9 exhibit unusually low concentrations of LDL cholesterol. So when you have lower amounts of PCSK9, you tend to have lower amounts of LDL cholesterol, which is considered to be cardioprotective. So to make it scientifically simple for everyone here, increased LDL cholesterol is bad for you. And increased PCSK9 means you have more degradation of the LDL receptor, which means you have more LDL cholesterol in your blood, which is bad for you. So therefore, we can safely assume that in this context, increased PCSK9 is bad for you. On the flip side now, when you have a reduced amounts of PCSK9, you have increased expression of the LDL receptor, therefore promoting more cholesterol from your blood, therefore reducing circulating LDL cholesterol, which is good for you. So to conclude in the most scientific way possible, therefore, in this context, reduced PCSK9 is good for you, and for those who like to party. So hopefully this makes a bit more sense to everyone now in the room. Now, during my master's, like every other historical grad student working late at night in the lab, I decided to one day grab some leftover Tim Hortons Americano coffee and dump it straight into a flask of liver cells. Don't ask me why I did that. But this led to us to discover that in literature, caffeine, which is what makes us everyone stay alive basically at this point, caffeine has been shown to reduce LDL cholesterol in your blood and considered to be cardioprotective. However, the mechanism as to how this is done has yet been unknown. And so therefore, because of the fact that PCSK9 plays a role in reducing LDL cholesterol, we pose the question, what are the potential effects of caffeine now on PCSK9? And so we were fortunate enough to have our findings published into Nature Communications, where we show that caffeine reduces PCSK9 to increase the LDL receptor to ultimately reduce LDL cholesterol levels. And so very briefly for our study methodologies, cell culture and animal studies were carried out using immortalized liver cells known as HepG2 cells and C57BL6 mice. The genetic expression of cells was assessed through quantitative PCR. The protein expression of cells and also in the blood was measured using ELISA and other methods like Western blot, IHC. And LDL cholesterol, the bad cholesterol, was measured using a fluorescently labeled dye known as DII-LDL. Now, so the first question we had was, is caffeine able to reduce PCSK9? And so we grabbed some of these liver cells, these HepG2 cells, and we treated them with various doses of caffeine. And what we saw was that caffeine was able to significantly reduce PCSK9 in a dose-dependent manner. So when you increase the dose of caffeine, we see a significant reduction in PCSK9 in all levels. As well, we saw that caffeine was able to reduce the genetic expression of PCSK9 in these liver cells, and consistent with our observations, we also saw that mice treated with caffeine also exhibited reduced amounts of PCSK9. Now, our second question was, is caffeine able to reduce LDL cholesterol? And so from those exact same mice using the DILDL fluorescent labeled dye, we saw that mice treated with caffeine had significantly lower amounts of LDL cholesterol. And at the same time, mice treated with caffeine also had increased expression of the LDL receptor. And so our premise and our conclusion was that when you treat yourself, when you treat mice, when you treat liver cells with caffeine, you will see a significant reduction in PCSK9, which increases the LDL receptor, thereby promoting more cholesterol from your blood and into your liver, and therefore reducing circulating LDL cholesterol. Now, our last question was, how can all this stuff be translated into a clinical therapeutic? And so we actually collaborated with an organic chemist at McMaster University, and we grabbed the structural backbone of caffeine, which is 1,3-trimethylxanthine, and we created 300 plus novel compounds and saw if they were also able to reduce PCSK9. And what we saw was that the majority of these compounds were able to significantly reduce PCSK9 far more potently than caffeine alone. And so this led us to file a patent in the hopes that we were able to push these novel compounds into the clinical realm. So this leads us now to the bench to bedside concept, where we see how bench-side research, going from animal models to cell culture models, all that caffeine stuff, how all that stuff connects to bedside care. So now having to file patent and all those good stuff. And so seeing how research is able to contribute towards clinical care was something that I personally wanted to pursue in my career and within my education. And so this led me to pursue the McGill MD PhD program, where you combine medical school with a 3 to 4 year PhD doctoral degree. And so it's a 7 to 8 year program. You do about 4 years of medical school, 3 to 4 years of a PhD. In McGill, at least, we get a $250,000 stipend throughout the entire program. It gives us a competitive academic edge for CARMS, which is how we apply for residency afterwards. And it's a great program, an absolutely great program to train for future clinician scientists who are interested in becoming physicians by training, but also run their own research lab. Here's a picture of Dr. Mark Eisenberg and I. He is the program director of the MD PhD program, and who's also the interventional cardiologist by training. And so this is also, I'm currently in my 3rd year within the McGill MD PhD program. So I've completed the first 2 years of my medical training, and am now on my 7th month of my PhD, which is looking at atherosclerosis in the context of reducing something known as ischemic stroke. This is a wonderful picture of our amazing McGill MD PhD students. Some of them are in my cohort. I swear we don't bite. So if you have any questions about the program, what it's all about, please do not hesitate to reach out to myself or to any of these wonderful people. Once again, I promise we don't bite. So this kind of leads us now to the end of my presentation, but before I finish, I want to show you guys a picture of all the pipette tips and boxes that I used in one night for the Nature Communications paper to prove a point that anything you do, which could be on a personal level or on the career level, requires hard, dedicated work. And it's a hard, dedicated work that will push you to, which is a necessity that will push you to achieve all of your dreams and goals. And man, when you achieve them, it's worth it. So with that, thank you so much for your time.
Thank you for your presentation. The floor will be open for 5 minutes.